Okay, yeah, this recorder is set. Okay, so let me just again start. Okay, so moment, concept of moment is simply this. This is how we calculate moment, but what exactly is moment? Let me just move this down. Okay, moment is actually it's kind of like moment is the turning effect of a force around a pivot. So what do we mean by that? By the turning force around a pivot point is okay. Like I mentioned just now, but I'll just explain one more time for the sake of the recording. If let's say you have an object, and let's say this arrow represents the force, when you apply a force on an object, the object will just move in the direction where the force is applied. But if let's say there's a screw, like a pivot point here, what happens is when you apply a force now, the object can't move like that, right? Because there's something that's preventing the whole object from moving. Instead, it's going to rotate due to the force applied. So there's a turning effect. Then you think about it logically. If the force is greater, whoops, if the force is greater, then the turning effect will be more. It's like when you push a door, you push a door gently or you push a door more, then what happens is the turning effect of the door increases with the force. Likewise, if you have the same amount of force, but you try to apply it at different positions, like here's a pivot, you apply a force very near the pivot, then you think, how is the object? Is it going to rotate a lot more or less? Then you apply the same force now further away from the pivot. Is it going to be a greater turning effect or a lower turning effect? So based on that, then they found that they can calculate moment using this formula. So let me just make it a little bit smaller so that it kind of fits on the Jamboard. So force in this case refers to the value of the force being applied. Let's say, okay, the value of the force of the arrow. Perpendicular distance is basically based on the direction of the force. Like let's say if the force is this applied downwards, the perpendicular distance from the pivot, center usually to center, this is the distance of the pivot and the force, perpendicular, meaning the force and this distance must be perpendicular. This is the distance you calculate. So logically, think about it. Greater force, greater moment. Greater distance, greater moment. Can follow so far?
Yeah.
Okay. So I want you to think about it. Like let's say you just apply the force on the door. Do you think, right, if is it easier to close a door when you apply the force closer or further from the hinge? Like that means, let's say for example, if this is the door. By the way, if you're wondering why I can see my face, is because I don't know, I find that and so studies have shown lah in terms of videos, right, that if you're just listening to audio without the video, right, it's actually harder to concentrate. When you see the fella talking, actually, right, it's easier to follow the lesson. It works for some, maybe it doesn't work for all, but I'm just going to go with it. Okay, so let's say for example, if this is a doorknob, and let's say here are the hinges, right? So here's the hinge. Okay, color. So I'm sure you've tried this before. If you try to apply, oops, the force, you try applying, like pushing the door close, applying the force here, like you push with your finger is best, like here or on the doorknob. Let's say A, B, and C. Which one, right, do you find that it's easier to close the door if just by pushing with your finger? Have you all tried before?
Probably C, because it's the furthest away from the pivot.
Yeah, but if you try it also, it's at C, right? It is the easiest to close. That's why the doorknob is always the furthest point away. It's not just because the door. It is the easiest to apply the force at C to close the door. So that ties in with momentum. So the further the distance, then the easier it is to close the door. That means the greater the turning effect. Can make sense so far?
Yeah.
Yeah. So moment is merely a physical quantity for us to just calculate. Like, okay, that's how you calculate moment. Sorry, I was going to say momentum. It's how you calculate moment. But as always with physics, there are laws and there's principles. That means if you want to solve a question using moments, like in what situation would we apply moments? So this is where we learn the principle of moments. So principle of moments is similar to the concept of balanced forces. Do you remember what balanced forces mean?
The forces unbalanced.
You just took the word and rearranged them.
But I tried. It's okay.
Let me just create a space here. Okay, Izzat, do you remember what balanced forces mean?
Is it when the force that is acting on an object is equal, like all around?
Okay, kind of, yeah, close. So balance forces, right, is when the resultant force or the net force is zero. So yeah, so that means yeah. So if you're thinking equal, it's normally because you're thinking of a situation where the forces applied on both sides. Let's say like applied to the left, applied to the right, it's equal, right? Or even if it's up and down, it's all equal. So that means what happens is you calculate the resultant force, you plus minus everything. In the end, whatever it is, when you calculate the resultant force is the single force that represents the combination of all forces acting on the object. Okay, that's not the official definition, but you can think of it that way. How you calculate resultant force is, or rather, the definition of resultant force is that it is the vector sum of all forces. That means if to the right you plus plus, if to the left you minus minus, basically you plus plus on all that, resultant force is equal to zero. So there are two situations for this. One is that it could be stationary, that means not moving, or it could be moving with constant velocity. So I'm not going to go into this because that's not related. I mean, somewhat related, but that's not the focus right now. So these two, it's because of a zero acceleration. That means from F equals, wait, why is it coming up? F equals ma, because the resultant force that goes in here is zero. So if F equals zero, that's why A is zero. That's why you get this. We're not going to go so much into this, but we'll focus on the stationary bit. So if the forces are balanced, that means yeah, equal forces on opposite sides, or if you total them all up, resultant force is zero. But that's for forces. In terms of moments, now, if we have an object that could rotate, let's say around a pivot point. Okay, let's say this is the pivot. Normally, no, normally in your questions, they don't do pivots like that. They normally balance it on a like this, like on a pivot, for example. Okay. So let's say this is like let's say like a seesaw, it's going to balance on something, so it can teeter totter, right? Now, if we apply a force here, what happens is this force will cause the plank. Let's say call this is a plank, right? And this is the pivot. It can cause the plank to rotate this way. That's clockwise direction. So this force, which I'll label as F1, can create a clockwise moment because it's going to cause the object to rotate clockwise. So the turning effect is clockwise. So I'm going to write here CW clockwise, okay, clockwise moment. If we have a force that is applied this side, say F2, it will cause the plank to rotate this way. And you find, oh, now it's going to go anti-clockwise. So F2 will create a moment or a turning effect that's anti-clockwise. So I'm going to write here as ACW, anti-clockwise. Sometimes you see them write CCW, that's counterclockwise, same thing, all right? Anti-clockwise moment. Now, principle of moments means this. Principle of moments is where we find that the moments are in equilibrium. So equilibrium means same thing as balance. So principle of moments, that means the moments are in equilibrium. So the moments are in equilibrium, that means that the anti-clockwise moment will be equal to the clockwise moment. How to calculate? this force times its own distance. Wait, let me just do this lah, easier. Okay, F2 times D2 will be equal to F1 times D1. Can follow so far?
But why?
Because it's not, because if it's in equilibrium means it's not moving, it's balanced.
Okay.
Yeah, it's like, imagine if you have a seesaw. And then okay, then you get lah, okay, one small fella. Okay, I know it's a ball, but imagine it's a person lah, okay, and then one big size fella. Then you put them both on the seesaw, like they're equal distance from each other. So do you think the seesaw will be balanced?
No, teacher, are you shaming big size people?
Yes. Okay lah, not big size. You can put, okay lah, put one baby and then put the older sibling. Okay, is that better?
Yeah, yeah.
Okay lah. So one younger child and then let's say an older sibling. All right. So is the seesaw going to be balanced?
No,
So the seesaw is going to, how is it going to be? Like which side is going to move down?
it depends. I have a TT and my TT is taller than me.
Okay, we now going by the mass here. Okay, so the circle represents the mass. Okay, so whether it's older sibling or younger sibling. Okay, the bigger size sibling and the smaller size sibling. Okay, because they're all still growing. All right, different ages. All right, they will grow at different rates. Okay, so which where, how will the seesaw be? Will it be balanced, or will it like rotate towards one direction?
It tilts to the side, which is more heavier.
Okay, so that means now it's going to rotate. Okay, wait, they'll move together lah. Okay, but just imagine lah. Okay, they will rotate. But let's say if we want to find a way, and if you go to the playground, we will always try this. Okay, oh, how can we get the seesaw to be completely balanced, right? So you can, if we could reposition these fellas, right? Who would be at the further end? The smaller fella, the lighter fella, or the heavier fella? Like, would you put this fella here or put it here? Like how? What would the positions be like?
The smaller person closer
Like that,
to
is
the
it?
pivot. Yeah.
What do you think? You can try in real life, take your ruler and then take one eraser and you see, can or not really,
Can, I think.
Izzat, what do you think?
I also think for the small one closer, maybe.
Why don't you try now? Take your eraser, you balance it on something, and then you take two objects, different weights, and see what effect you get. Yeah, I don't have a ruler at the moment. I didn't bring mine. I didn't bring my ruler. But you think lah, like you have to try in real life, because if I just tell you, you're not going to see it. Go and get your ruler. Does it have a ruler? Does this center have a ruler? Okay, you try and see. You take ruler, and then you see. If you take the heavier object and the lighter object and place it, how's it going to be like? Can balance?
Yeah, put the heavier one closer to the pivot. Yeah, I just tried it.
Then it's possible, right?
Yeah.
Yeah. So the heavier object should actually be closer, and this one actually further. It's possible.
Since you're in the center,
Come in.
you're in the center.
You mean here? If you're in the
Yeah, no,
center,
no, I mean,
if you're in the
you're
center,
in the physical center.
if you put in the center, there's no more turning effect. Then it's a different kind of problem already. So
No, no, I mean, you're in the physical tuition center.
oh, oh yes, I'm in the center. Oh, that's what you mean. Yeah, yeah. I came here because there was the previous class there was a student who came physically. Yeah.
Do we have to go physically?
The one you discussed with the center because I'm not entirely sure what's the arrangement like actually.
Oh, okay.
Yeah.
Because I'm not allowed to go out, so yeah.
Oh, okay, okay. Uh, okay. I don't know because like I understand sometimes the we were still a bit concerned about the COVID-19, so a lot of parents and students still prefer not to leave the house yet. Yeah. So if you still want to do it online, I think it's fine, but discuss with the center lah, how it should be done. Yeah.
Okay, thank you.
Okay, so anyway, yeah, if you can keep trying. If you take a longer ruler, you can probably see it more clearly. If you take the heavier object and place it closer, it's actually possible to balance, even though they have very different masses or different weights. Actually, yeah, because in the end, it's about comparing the moments. Okay, if you see, if let's say for example, if you're talking about the weight of this object, let's say W1, and distance from the pivot is D1. So W1 D1, whoops, what's this? What kind of writing is that? W1 times D1 because weight times the distance, that's the moment. And then you have W2, whoops, W2 and D2. So if let's say right, this W2 is greater, so I'm gonna write short like the maths way, right? If W2 increases, then D2 needs to decrease in order to balance out W1 D1. But if you don't believe me, you have to try it in real life. Like take a ruler, balance it, and then you see. Or you go to the if you can go to the playground. Okay, you can't leave the house, then you can't go to the playground lah. So you have to try this at home lah. Just take the long ruler and then you try to balance it and see if you can somehow balance it. Balance two objects with different weights on either side and see whether you can balance or not. Okay, so this is in theory. If you don't believe me, go and do it in practice. See whether it can balance. So it can be balanced, but you have to try to find that distance. But yeah, the heavier object needs to be closer to the pivot compared to the lighter object. Okay, make sense?
No, thank you.
Okay. So sometimes you will come across questions where it's not just a single moment on either side. Let's say you have a situation and be careful, right? It's not always the pivot in the center, but let me do this first. I'll explain this one. So let's say usually they place a pivot in the middle, and there's a reason for this. I'll explain in a moment, but I'll talk about multiple forces first. Like let's say if you get a situation where you have a force like this F1, then you can even have a force like this F2 from the bottom. It's even possible. Now, just because they're opposite sides doesn't mean that they are going to balance each other out. You see, F1 is going down, is going to create a turning effect this way. This is clockwise, so you get a clockwise moment. Now, so means you always check around the pivot. You imagine, put the pivot there, and you see, oh, the force goes this way, right? Yeah. So then you see, how does it rotate around here? Then you see F2 pivot is here. It's going to rotate this way as well. Then you check, oh, clockwise also. So which means that there are two clockwise moments now. So this one, right, will not be in equilibrium. It won't be balanced because it will end up rotating clockwise. Because this one clockwise lagi is going to rotate lah. So sometimes you can have a question where there are three or more forces. So let's say we have another force acting, let's say this way, F3. Then you see, right, this force F3, it's going this way. Then you see, it's going in the opposite direction, it's going anti-clockwise. So F3 is going to create an anti-clockwise moment. Now, the question won't tell you using principle of moments. They won't do that, but they will tell you like maybe like um, this plank is balanced or this plank is not moving and not rotating, it's stationary. So they will phrase it differently. So if it's not moving or if it's stationary, it means it's balanced. No? So if it's balanced, that means you can take the clockwise moment because it's not moving, right? It's stationary. Clockwise moment will be equal to the anti-clockwise moment. So now this time, clockwise moment, there's two. So you need to add them both together. That means, let's say if this is F2 and D2, so you measure it from the pivot, F3, D3, and then F1, D1. That means the clockwise moment, there's two, right? So you have F1 times D1 plus F2 times D2. So it means you count moment for this, add together. And then the clockwise moment would be F3 times D3. So sometimes you have multiple moments like this. And what you do is you just like multiply, get a moment, plus for the same turning direction equals to the same turning direction or the opposite turning direction rather. Can follow so far?
Yep.
Okay. Also, I'm just throwing you a lot of information here, but because later when you do some questions, you're going to see different kinds of moment questions. So I might as well like give you the basic information to solve most questions. The reason why they always place the pivot at the center, is because, okay, what happens is now even the plank has weight, and the plank can also cause a moment to occur. But if you place the pivot directly at the center, remember the weight of the object is at the center of mass. So if it's sometimes you will use a term like uniformly distributed. That means this plank, like a meter rule, the weight is uniformly distributed, which means the center of mass is center. So here is where the weight would be. If you place the pivot directly at where the center of mass is, there is no turning effect because it's zero, distance is zero. That means it can't turn because where the weight is acting, where the force is acting, that's exactly where the pivot is. So there will be no turning effect. But never assume the pivot is in the center. Always check the question because sometimes the question just to test you, right? They'll put the pivot somewhere else. So the moment the pivot is somewhere else, even though there's no other forces acting on it, you think logically lah. Okay, let's say like like how we always try to balance. Ooh, so where it's oops, where we can completely balance the pet. Oh my god, I suck at this. Where we can completely balance it, right? That means the center of mass, right, is there. The weight is being pulled and is now being balanced by my finger. So that's why now it's balanced. It's not rotating. But if my finger, like just now, it kept falling, right? Because I couldn't find the center of mass. So if I put it here, the pivot now is somewhere else. The pencil will fall. Okay, so the pencil falls because the weight is the force applied here that creates a turning effect. So the further away, of course, the faster it falls. That means the greater the turning effect. So in this case, the weight can also create a moment. And the further away it is from the pivot, then the greater the turning effect. So how you calculate a moment? Also same thing, weight times distance. Okay, can follow so far?
Yeah, but in a question, will there ever be two pivots?
Possible, yes, if you have two pivots. Okay, how to solve if two pivots? If there are two pivots, you can't solve both pivots at the same time. You have to, you actually have to take one at a time. So that kind of question, right? If you have two pivots, oops. Okay, if you have two pivots, right? Okay, so let's say, for example, you have a question like this. So they will apply a force F1 here and a force, let's say, F2 here. So if you have this kind of questions like, oh my God, how to solve? So what you do is you take one pivot, ignore the other pivot. That means let's say, for example, this is pivot 1. Let's label this lah, pivot 1, pivot 2. So when you want to solve, let's say like, okay, they say, oh, the object, this one now is balanced. Okay, so everything is balanced at the moment. So remember that, okay, this one, there's weight acting this way. Now, how to solve whatever question depends on the question lah. But let's say if you have to count certain things, right? Then what you do is when you solve it, you solve one pivot at a time. That means you focus on pivot 1. Oh, by the way, yeah, there's a pivot 1, right? That means there is actually a supporting force acting upwards, which we can there's a force because it's supporting one, there's a reactional force. So we'll label this as, let's say, P1, and then there's another force here, P2. Wow, so many forces. Unfortunately, that's the way it is. All right. So let's say, for example, if you have to solve any particular question, what you do is you see the question, see the situation. Let's say we focus on pivot 1. That means if we focus on pivot 1, taking pivot 1 as the main focus, that means you look at it as F1 is going to create a clockwise moment. So I'll just draw a circle here. It's a anti-clockwise moment here. Weight will create a clockwise moment. F2 will create a clockwise moment. And even this P2 is actually creating a moment anti-clockwise because there's a force over here. That means around P1, or not around P1, around pivot 1, principle of moments, you would take let's say here, F1 D1. Wait, let me do it this way first. Anti-clockwise moment equals to clockwise moment. Then you take, okay, F1 D1. This one clockwise moment. So this one goes the other way. So that means, let's say, for example, if this is, let's say this is D3, because I want to take this as D2. So then that means, right, okay, clockwise moment, this becomes W times D3. This P2 here, let's say D4, clockwise moment plus P2 times D4. Then F2 is clockwise moment, F2 times D2. So that means, so I know there's a lot of labels here, but you think of it this way. Everything you calculate, you find it around P1. So all the rotation here, all find around P1. Then it's like if you need to solve it around 2, can also. That means, right, let's say around P2, around pivot 2. That means now if it's around pivot 2, this is, I think I better start a new diagram because it's going to be very confusing. Because now it's like too many arrows, right? Too many things. Let me just duplicate this. Okay, so let's say around, let me rub this off. Where's my pen? Where's my pen? I can't see it. Oh, there it is. So that means, right, instead of taking around P1, you can actually take it around P2 now. So around, that means you check around pivot 2. So this time, your F1, right, the D1 is much, much further. So I'm just going to erase this so that it's, so that you can see better. That means now you take F1's distance not from here to P1, but from here all the way to P2. This becomes the distance for F1 now. Then F2, this is the distance. Okay, then you see, okay, F1, how? F1 is going here, still going anti-clockwise moment. Okay, so that's F1. But then, where's my eraser? Okay, but then for the weight line now, the weight, we are not measuring from P1 now. You need to measure the weight line from P2. So that means now this is the new, this is not new, this is the distance for the weight. Let's call this D3. And now weight is, it's not going here now, it's around P2. It's now, oh, creating actually an anti-clockwise moment. P2 now on itself, tak ada moment, but P1 is creating a moment that's going upwards. It's going to go and give a clockwise moment. So that means when you have two pivots, you actually have to take one pivot and then you ignore the other pivot, but take into account the force from that pivot. So now you have, let's say, anti-clockwise moment equals to clockwise moment. So this one will, that means anti-clockwise here is F1, right? So F1 D1 around P2, okay, plus the weight times D3. Clockwise moment there, you have F2 D2 plus P1 D4. So if you look at this one, like, so confusing. But no, basically what you do is you have two pivots. You label all the forces first, then you take one pivot, just focus on one pivot, all the forces rotating around that pivot. Or you take the other pivot point, all the forces around that other pivot. Can follow? I don't expect you to understand straight away, but can follow?
I think my brain went into the deep fryer.
I think you have to do the questions. When you do the questions, then it becomes clearer because now it's like, oh, what's going on? So if you have the questions and you see numbers, it might be a little bit easier. Okay,
Okay.
so I'm going to give you some questions shortly, but so I'm just going to touch one more thing. It's not in the worksheet, but it has come out in a past year question before. I always mention perpendicular distance because there have been occasions where they give questions, right, where the force is not acting perpendicular to the object. Like let's say, for example, right, let's say this one is this plank that's it's been screwed to the wall over here, and then the force applied, right? The force applied is like this direction. So when you have this, you cannot take F times D and say, oh, this D is like this. Oh, from the pivot. No, cannot, because this is the wrong angle already. Cannot. It's wrong. So which means that when you want to when you want to determine the distance, right? Distance is perpendicular like this. So even though the plank is like this, you apply a force this way, you measure the distance perpendicular from the force to the pivot. Just to let you know. Okay? Can follow so far?
Yeah.
Okay, never mind. Tell you what, up to here first, because learning concept like this, it can be very confusing, but sometimes, interestingly, when you do the questions, it becomes a lot clearer. So what I'm gonna do, okay, I'm gonna stop the recording because I'm gonna give you questions now. Okay, let me stop the